Hello everybody, I would like to welcome you to our 15th video in the pre-algebra playlist. And in this video we are going to go over solving equations which involve division and multiplication. Now before we begin, I would like to go over some notations that we will apply from now on. Now so far you have seen this symbol over here to represent division, but from now on I am going to use the fraction bar to denote the operation of division. So if I have some number a and some number b, and I want to say a divided by b, I used to write it like a divided by b over here. But from now on, I'm going to use a divided by b. So for example, if I say 6 divided by 3 equals 2, I'm going to denote that as 6 divided by 3 equals 2 from now on. Now, before we get on with solving equations involving multiplication and division, I would like to go over two properties, and those two properties are the multiplication property of equality and the division property of equality. Now, similar to the last video, let's say I have some number a and then I have some number b. In this case, if both a and b are the same number, I can denote that as a equals b. Therefore, if I have some number c, and if I'm multiplying both sides of this equation, a equals b, by that number c, I can denote that as a times c equals b times c. And this right here, a times c equals b times c, is known as the multiplication property of equality. Now, similar to the multiplication property of equality, let's go over the division property of equality. Let's say I have some number d, some number e, and some number f. Now if d and e are the same number, I can denote that as d is equal to e. Now, if I divide both sides of the equation, d equals e, by the number f, I can denote that like this over here. So now I have d divided by f equals e divided by f. Now, one important thing to realize is that the variable f cannot represent the number 0. This is because division by 0 will give you an answer of undefined. Now let me go over two properties that we will use extensively when we're solving multiplication and division equations. Now these two properties are basically what we know as the inverse operations. In the last video, when we were dealing with solving equations with the operations of addition and subtraction, we learned that in order to isolate the variable and get it all by itself, we need to have a 0 on the side of the variable. But when we're dealing with multiplication and division, we need to have a 1 instead of a 0. Because if you multiply something by 1, you will get that variable all by itself. And if you divide something by 1, you will get that variable all by itself as well. So let's say you have some number a, and if you divide a by a, you will get 1. Similarly, let's say you have the division of a and b. So I denote that like this over here and read it as a divided by b. Now if I multiply the division of a divided by b by the number b, I will end up with whatever is on the top. In this case, a divided by b times b is equal to a. So let me show you an example of this. If I have something such as 2 divided by 2, I can denote that by writing the fraction bar between the two 2's and read it as 2 divided by 2. This will definitely give me a 1. Similarly, if I have something such as 9 divided by 3, and if I multiply that by the number 3, I will get whatever is on the top. In this case, I will get the 9. So now let's go over a few examples in which we actually solve equations. So in this first example, let's say I have something such as x over 9 equals 3. What I really want to do is find some way to get the variable x all by itself on one side of the equation. Now in order to do that, I refer back to the last page and realize that if I have some number a, and if I'm dividing that number by the number b, and if I multiply that quantity by the number b, I will be left with whatever is on the top. In this case, I'll be left with the number a. Similarly, in this problem, if I want to get x, which is on the top, all by itself, all I really need to do is multiply both sides of this equation by whatever is on the bottom. In this case, the bottom is the number 9. So I have x divided by 9 times by 9 on my left hand side, which basically cancels out the two 9's, and I'm left with the variable x all by itself. Now on the right hand side, I have 3 times 9, which will give me a 27. So 27 is my solution. Now if we check it, all we really need to do is replace x in the original problem by the number 27. And since 27 divided by 9 is indeed equal to 3, and 3 is equal to 3, I have a true equation over here, and therefore 27 is my solution. Now let's do another example. Let's say you have something such as 8x equals 24. Now if I want to isolate x all by itself, all I really need to do is find some inverse operation that will give me a 1 over here instead of an 8. And so the appropriate inverse operation for 8 times x would be to divide by 8. We learned in the last page that if I have some number a, and if I divide that number by a, I will be left with 1. So if I divide both sides of this equation by the number 8, I will be left with 1 as a coefficient for the variable x. The two 8's cancel each other out, and I'm left with only the x on the left hand side, and then 24 divided by 8 on my right hand side. You can further simplify 24 divided by 8 to give you a final answer of 3. Now if I want to check it, all I really need to do is replace the number 3 for the variable x. So 8 times 3 will give me a 24, and 24 is equal to 24, so I have a true equation over here. So 3 is indeed the solution. Now let's step up our game a little bit and combine everything that we know about solving equations together. So in this third example, let's say you have something such as 6k plus 3 equals 21. All you really need to do is take it step by step. You know that when you're evaluating an expression, you follow the order of PEMDAS. And so you can think about solving an equation as the undoing of PEMDAS. So you need to follow the reverse order. So when you're solving an equation, instead of following the order of PEMDAS, you need to follow the order of StatMap. So the first thing that we really need to do is figure out a way in which we can isolate the variable k all by itself. In order to do that, first we really need to get rid of the plus 3 term over here. And so the appropriate inverse operation is subtracting both sides of the equation by the number 3. Now when we simplify this, we get 6k on our left hand side, and we get 21 minus 3, or 18, on our right hand side. So we need to perform the appropriate inverse operation of dividing both sides of the equation by the number 6. And when we do that, the two 6's, one on top and one on the bottom, cancel each other out to give me a 1. And so I have k on my left hand side and 18 divided by 6, which is equal to 3 on my right hand side. So the solution to this equation is k equals 3. Now if you plug back 3 in for k in the original equation, you get 6 times 3 plus 3 equals 21. And so 6 times 3 is 18, and 18 plus 3 will give you 21. So this is a true equation, and k equals 3 is indeed the solution of this equation. Now let's say you had something such as 2x divided by 3 minus 8 equals 100. So we start out by undoing the s, which is a subtraction. So we need to find the appropriate inverse operation of negative 8, and we know that that is equal to adding 8 to both sides of the equation. So on my left hand side, I get 2x divided by 3, and on my right hand side, I get 100 plus 8, which is equal to 108. Now the next thing that I need to do is get rid of the 3 on the bottom. And in order to do that, I need to perform the inverse operation of multiplying both sides of this equation by the number 3. Now the 3's will cancel out on the left hand side of the equation, and I'll be left with 2x. On the right hand side of the equation, I'll be left with 108 times by 3. That will give me 324. Now on the left hand side, I have 2 times x, so I need to perform the appropriate inverse operation of dividing both sides of this equation by the number 2. And when I do that, the 2's cancel out to give me a 1. So basically x all by itself, and 324 divided by 2 is equal to 162. So the solution to 2x divided by 3 minus 8 equals 100, where we are trying to solve for x, is 162. Now let's go over one more example before I leave you in this video. So in this example, let's say you have, if Nea has 68 children in her daycare in 2015, which is 4 times the children she had in the year 2014, how many kids did she have in her daycare in 2014? Now there is a second part to this problem, but let's just solve the part in the blue first. So in this case, we can denote the number of kids that Neha had in her daycare in the year 2014 by a variable. You can choose any variable, but I'll choose the variable A. Similarly, I'm going to denote the number of kids that Neha has in her daycare in 2015 by the variable B. Now let's come up with an equation which relates A and B with one another. So I can start out by writing the variable B on the left hand side, which will represent the kids in daycare in 2015. And we know that that is equal to 4 times the kids that she had in her daycare in the year 2014, which is represented by the variable A. So B equals 4A relates the children in Neha's care in the year 2014 and 2015 with one another. So our life becomes a little bit easier because we actually know the number of children in Neha's daycare in 2015. That is 68. So I have 68 equals 4 times the children in the year 2014. In order to solve or isolate the variable A by itself, I need to perform the inverse operation of dividing both sides of this equation by the number 4. And when I do that, I get 68 divided by 4, which is equal to 17 on my left-hand side, and simply the variable A on my right-hand side. So Neha had 17 children in her daycare in 2014. Now for the second part of the problem, it reads, if she expects to have 6 times the kids as she did in 2015, in the year 2016, how many children will Neha have in her daycare in the year 2016? So similarly, I'm going to write the number of kids in Neha's daycare in 2015 by the variable B. And I'm going to denote the number of kids that Neha has in her daycare in 2016 by the variable C. So an equation that relates the number of kids in daycare in 2015 with the number of kids in daycare in 2016 can be written as follows. C equals 6B tells me that in 2016 the daycare is expected to have 6 times the number of kids as it does in the year 2015. Now I know that in the year 2015, the daycare has 68 children, so I can replace the variable B by the number 68. And when I evaluate 6 times 68, I get that C is equal to 408. So the daycare is expected to have 408 children in the year 2016. Now, before I leave you in this video, I would just like to go over one quick thing, and that has to do with notation more than anything. So I'm just going to make space over here because this won't take a lot of time. In this video, in the beginning, I introduced you to the new notation of writing the division, which is with a fraction bar. So instead of writing A divided by B, I can denote that as A divided by B with a fraction bar like this over here. Now, just for the sake of terminology, the number A, which is on top of the fraction bar, is known as the numerator. Similarly, whatever is on the bottom of the fraction bar is known as the denominator. So that's it for this video, and I hope you enjoyed it and you learned a lot from it. I hope you keep on working hard, and I'll see you in the next video.